Welcome to our course on serving a machine learning model with FastAPI and Streamlit. My name is Franklin Allen. This course is designed to help you learn how to serve a machine learning model with FastAPI and Streamlit application frameworks. Whether you're a beginner looking to learn the basics or an experienced professional seeking to improve your skills, this course has something for you. We'll start with the fundamentals and gradually progress to more advanced concepts, ensuring that you have a solid foundation on which to build your knowledge. Throughout the course, you'll have access to video lectures and slides that will help you practice what you've learned and reinforce your understanding. Additionally, I will be available to answer your questions and provide feedback on your progress. By the end of this course, you'll have the knowledge and skills necessary to serve a machine learning model. Whether you're looking to boost your career prospects or simply expand your horizons, this course is perfect for anyone interested in machine learning. Before we get started with the remnants of this course, I would like to demonstrate a working overview of the application we're going to be developing throughout this course. So this is the user interface of the application, and we're going to select an image from a list of images I downloaded prior to this course to recording this video. So we're going to select it. Then we're going to select a style from the list of styles available in the application itself. Then we're going to generate some styles. So the first style generated is the style selected from the list of available styles. Then the application goes ahead to generate other styles from other available models in the AI. So here are other available styles that is being generated concurrently. So what exactly is the application we're going to be building? We're going to be building a style transfer application based on the perceptual losses for real-time style transfer and super resolution paper and Justin Johnson's pre-trained models. We'll use FastAPI at the backend to serve our predictions, Streamlit for the user interface, and OpenCV to do the actual prediction. Docker will be used as well. One powerful feature of OpenCV's deep neural networks model is that it can load trained models from Torch, TensorFlow, and Caffe, effectively saving us the trouble of installing those dependencies. By the end of this tutorial, you should be able to develop an asynchronous API with Python and FastAPI, serve up a machine learning model with FastAPI, develop a UI with Streamlit, containerize FastAPI and Streamlit with Docker, and leverage asyncio to execute code in the background outside of the request response cycle. So I'll see you in the next video. Machine learning is a hot topic at present, with technology companies moving in the direction of artificial intelligence and machine learning to cash in early. The field has grown tremendously large. Many of these companies create their own machine learning solutions and sell them to others using a subscription-based model. Since the majority of machine learning models are developed in Python, the web framework that serve them up are usually Python-based as well. For a long time, Flask, a micro framework, was the go-to framework, but that's changing now. A new framework designed to compensate for almost everything Flask lacks is becoming more and more popular, and it's called the FastAPI framework. FastAPI is faster than Flask because it brings asynchronous function handlers to the table. As you can see from the figure above, FastAPI is almost 3 times faster than Flask. The third position is held by Starlet, which is the server that FastAPI is built upon. FastAPI also supports data validation via pedantic and automatic API documentation generated by the OpenAPI specifications based on the Swagger documentation. Streamlit is an application framework that makes it easy for data scientists and machine learning engineers to create powerful user interfaces that interact with machine learning models. Although Streamlit can be used in production, it's best for rapid I'll see you in the next video. So, in this video, I'm going to be walking you through a series of steps to install Docker on your system. So, if you're taking this course, I'm sure you already have a brief overview or kind of some knowledge on how Docker works or what Docker is used for. So, Docker is just a software for running or building applications in containers that contain like an ecosystem of that's application specific dependencies. So in order to install, so installing Docker on Mac is kind of straightforward. You just go to this URL here highlighted. Then to install Docker on Mac, you will navigate to Docker Desktop for Mac. Then open URL and go through the requirements required. Then if you meet the requirements to install Docker on Mac, you can go ahead and install it. Then installing Docker Windows is a bit tricky because you have to make sure that you meet several of these requirements. Of course, you need to have Windows 11 64-bit Home or Pro version or this Windows 10 64-bit Home or Pro version, and you also have to enable the WSA2 feature on Windows using the um using the terminal, or if you have the Pro version, you just need to use the Hyper-V backend and Windows containers, which already comes pre-configured on the operating system. So I'll recommend you navigate to this website to install Docker on Mac or Windows and go through the requirements. Then if you have any issues, you can raise them through the course instructor communication channel. I won't be providing any setup um, guidelines on installing Docker on Linux because it's more advanced for this course. So in the next videos, we are going to begin setting up our project for setting up our workspace for the projects we are going to be working on throughout this course. So I'll see you in the next section. Thank you. Welcome to this section. In this video, we are going to be setting up our development workspace for our project's workflow. So open up your terminal and navigate to your working directory. Then create a folder called style transfer in your working directory. Then you navigate to the folder you just created. Then you create two new subdirectories inside the folder you just created. Then you launch your code editor inside the project's workspace. So since I'm using the VS code editor, I'll be launching my code editor with the code command. So this is my editor. Then inside the backend subdirectory, create a new file called requirements.txt. Add the following requirements inside the file. After writing down the requirements in the requirements.txt file, open your terminal and navigate to the backend directory that we can install the requirements in the virtual environment. So first you have to create your virtual environment. Since I'm using the ppm virtual environment, I'll create the virtual environment by using the ppm shell command. But that depends on whichever virtual environment procedure you're using, whether it's the venv, the ppm, or the ppvmv. So since for this course, we'll be using the ppm shell. So I'll create my virtual environment with the ppm shell command. Then while that is creating, I'll also go back to the code editor and create another requirements.txt file for the front end subdirectory. Then I'll add the Streamlit requirement into the file, then save it. Then go back to the terminal, and once your virtual environment has been created, now it's time to install the requirements into the virtual environment. So in your terminal, type the following command: ppm install, and you have to read the requirement file. Then wait for the requirements to finish installing. Now that the requirements have been installed, it's time to start working on building the FastAPI backend. So in the next video, we are going to begin working on on writing the code for the FastAPI backend, and we'll go on from there. See you in the next video. In this video, we're going to work on the FastAPI backend. So add init.py files to each of the backend and the frontend folders. Add a new file to backend called main.py. Add the following code to main.py. Next, add the following configurations to a new file called config.py. You can copy the configurations from the config file in the source code attached in the first section of the project. So open the source code attached in the first section of the project and go to the backend. Then open the configurations file, and you can copy the code there and paste it in the config.py file in our current project. File. When introduced, style transfer was a game changer. The only disadvantage was that the image had to be trained to obtain a style for it. This means to get a styled image, you need to run through the original images multiple times before getting a better result. In 2016, the perceptual losses for real-time style transfer and super resolution paper introduced fast style transfer, which means you can style any image in a single pass. We are going to use the same technique with the trained models provided by the author. Now we need to download the models, add a script to the project root called downloadmodel.sh. You can copy the code for downloading the models from the source code. So open the downloadmodels.sh file located in the source code attached in the first section of the file. Then copy and paste the code for downloading the models to our working file. Now to download the models, open your terminal and navigate to the project root. Then sh run the download file. Sh download sh download the models to our local storage. After the models have been downloaded, we are going to write our inference function to process the image from the models. So create a new file called inference.py and add the following code to it. Here, we loaded the touch model, performed resizing, and the blob format, converted it to blob format required. Then we passed the preprocessed image into the network model and obtained the output. The post-processed image and resized image are returned as output. Let's add the inference functionality to our API style route handler. We are going to add the inference functionality to the view function required to perform the image processing functionality view function handler. Add the following code to the get image function. So this is our server. FastAPI creates two endpoints, one dummy home URL route handler and one for serving our prediction style. The serving endpoint takes in the name as URL parameter. We are using 9 different train models to perform style transfer. So the path parameter will tell us which model to choose. The image is accepted as a file over a post request and sent to the inference function. Once the inference is completed, the file is stored on the local file system and the path is sent as a response back to the client. In this video, we are going to be setting up our server application to run in a Docker container. First, add a Docker file to the backend folder. Then, copy the contents of the Docker file from the source code attached in the first section of the course. So, copy the code, paste it in the Docker file. The FFmpeg, libsm6 and libxcx-t6 are required for OpenCV. From the backend folder in your terminal, build the Docker image. Sorry, build the Docker image from the current directory. After we build the Docker image, we're going to run the Docker container. Then we're going to open this URL in our browser. So launch a new browse, a new Chrome instance, and go to localhost 80, and see our welcome message from the API endpoint we wrote in the main.py file. When you launch the browser and you go to the localhost of the address listed in the in the terminal, you will see your response message from the API, which is the code, the message we wrote in the main.py API endpoint. And when you see this message, you know that your code is working correctly. So you can queue the server instance in the terminal. In the next section, we'll be working on the Streamlit front end. See you in the next video. For the UI, add a main.py file to the front end folder. Add the following code to the file. Copy the styles from the configuration file in the backend folder and paste in the main.py file on the front end subdirectory. Then add the remaining code to the file. Take note of the code comments above. Put simply, we created an upload image widget along with a select dropdown displaying each of the styles from the style dictionary. We also added a button that, when pressed, sends the image to the backend as a post request payload to the backend style URL. Upon receiving the image part in the response from the backend, the image is opened and displayed. Refer to Streamlit's Get Started guide and the API reference for help with displaying text and data, as well as adding basic interactivity with widgets. In the next video, we'll be dockerizing the front end and wiring both the front end and back end containers together with Docker Compose. See you in the next video. In this video, we are going to dockerize the front end and wire both containers, that is the front end and back end containers together with Docker Compose. Create a Docker file in the front end subdirectory. Add the following code to the Docker file. Next, create a Docker Compose.yml file in the project's root directory. Add the following code to the Docker Compose file. The most important thing here is that we mapped the storage of the host machine to the storage of each container. This is important for sharing the path and also to persist data when spinning down the containers. Thus, both the backend and front end can access images from the same shared volumes. To test the application from the project's root in the terminal, view the images and spin up both containers. After the containers have been built, return back to the inference.py file and change the following piece of code to equal to sign and save the file. Then open your terminal and rebuild the containers again. Then to test the application, since we mapped the front end port to 8501, launch a new browser instance and navigate to localhost 501 and test the application. Upload any image file of your choice to the application. Then select any of the available styles and click on the style transfer button. You'll see a newly generated style in your user interface. But we are not done. In the following sections, we are going to be generating an image with all the following styles asynchronously from the backend server. So I'll see you in the next video. Now that you have seen how to use FastAPI, Streamlit, and OpenCV to perform a style transfer, let's do a little experiment. One of the most powerful features of FastAPI is that it supports asynchronous functions. So let's leverage an async function to convert the input image into multiple styles. We will process the first image synchronously and then send back the response as the remaining models are processed in the background. Add the following functions to backend/main.py. The generate remaining models function generates each of the remaining styles using the asyncio Python library for asynchronous programming. Updates the get image function so that it creates the asynchronous tasks before sending the response back to the client. In the next video, we are going to update the code for the client to accurately respond to the response from the FastAPI server. See you in the next video. After the first prediction is made, we'll delete the style from a copy of the original styles. Then the remaining styles are passed to generate models. In this video, we are going to be coding up a change for the front end to enable it to respond effectively to the response from the FastAPI server. Make the following changes to the code. Before we continue, open the main.py file in the backend directory and up, change the following piece of code. So update the process lookup error to process old executor. Also change the get image view function to an asynchronous function by adding the async keyword in front of the function. Save the file. Call the inference function from the inference file to access this functionality. Then return to the main.py file in the front end directory. Set the width of the image display to 500 pixels. Save the file. So just a little rundown of the code we just wrote. After displaying the first style, we continue to check for the remaining styles, displaying each until all 9 are on the page. So open the terminal and rebuild the containers. After the containers have been rebuilt, open a new Chrome instance and navigate to the URL for application. Select any image of your choosing and select any style to be the first one. Then click on the style transfer, and now you'll see that the remaining styles will be generated asynchronously without blocking the initial response from the API endpoint. And now we have built our application. So, in conclusion, FastAPI is a modern async alternative to Flask. It has a lot of features that Flask lacks and is faster than Flask since it leverages starlets and supports asynchronous function handlers. FastAPI has a lot of additional features like data validation, automatic API documentation, background tasks, as well as powerful dependency injection system. Plus, since you'll almost likely be taking advantage of Python type hints, that is so you can leverage data validation, you'll be able to move faster in development due to editor auto completion and automatic error checks. Thank you for joining me in this course. You can find the final code for the course project in the source code folder in the last section of the course. Thank you, and I hope you subscribe to my other courses. Thank you.